Hello friends, welcome back to my channel Varteta Learning Platform, and in today's video we are going to discuss how we can implement the shared PTR. You must have studied about the shared PTR in my previous video in which we have included this memory header, and then we have used this standard shared PTR which was provided by the library. Now we are going to write our own shared PTR with name underscore shared underscore PTR. So let me write the class here, shared PTR. Okay, so you need to create four things. First of all, let me just do the first thing, which is then write like template class 3. Then it should be a public section. And before the public section, since you know that in previous video we discussed how it maintains the count, right? So resource count, we leave it here and it should be static, right? So this is like static int resource count, and now let's start writing the constructor. So the first constructor is shared PTR, doing nothing. Then write like shared PTR, which takes one argument, and what it does, it simply assigns this to P is equal to P, right? And then we need to write the copy constructor and the assignment operator. Both are workable in shared PTR. We have seen in the previous video that standard shared PTR allows both the operations, the assignment operation and the copy constructor operator also can be called. Okay, so the copying of the object is also allowed, and the assignment of one object to the other object, that is also allowed. So let me just write the copy constructor here, sp, and then the assignment operator is equal to, and then shared PTR, sorry, not this shared, rather this shared, sp. Okay, now first of all let's implement. So you know that we have to increase the count, okay, because we are maintaining the resource count using the shared PTR. So it will be n resource count plus plus, and along with this what we need to do, sp dot p, sorry, p is equal to this dot p, this to p is equal to sp dot p. That's it. So we are increasing the resource count, and at the same time we are assigning the pointer which came into this shared PTR into our current class object, into our current class p of the current object. Okay, same thing you need to do here, n resource count plus plus, and this to p is equal to sp dot p, right? And you need to write two more things, since the move operation is also allowed. So you need to write the third thing as the move constructor. How you write the move constructor, we have seen it in the unique PTR videos. So let me just write it, shared PTR, and then it's like shared PTR sp. You know, we use the ampersand sign here. So when you use the move PTR, in that case you need to remember that you don't need to increase the resource count. First thing, you don't need to increase the resource count, because in case of move you will be moving the not moving exactly, basically you will be pointing another object, another smart pointer to the same location which the other pointer, like this is smart pointer shared ptr which you have passed here. This shared ptr was pointing to some location which was pointed to by p. Now this p will be pointed to by this current object, and this object, right, shared ptr, represented by this object sp, that should be pointing to a null pointer. That should not be pointing to this memory area anymore. Okay, so what we need to do, first of all, dot increase the count, resource count, and then what you need to do, you need to do one thing, like this to p is equal to sp dot p, and then sp dot p is equal to null ptr. That's it. Okay. Okay, now what you need to do, you need to write one more function, and that is the overloaded assignment operator for the move operation. Okay, so you can use the move operation using the copy constructor and using the assignment operator. So what you need to do, operator equal to share ptr like this, and now what you need to do, again you don't need to increase the uses count. Basically the correct word that should be used here, not the resource count but uses count. Okay, again do the same thing. You can do one thing, like you can just put this piece of code in some, in some macro, and just use that macro here, so that way you don't need to write the same piece of code again and again. Okay, so this to p, sp.p and sp.p is equal to null ptr. Now the very basic thing we have to implement, and that is the overload asterisk operator, and then overload the pointer to member operator. These two are very much important. I mean, these two are the mandatory operators which you must need to overload for your class to become a smart pointer class. Okay, so let me write it. So it's like t asterisk t reference of operator asterisk, and it simply return asterisk of p. And if you write this t asterisk operator pointer to member operator and then overload it, what you will return p. So this is how you can implement your entire shared pointer class by yourself, right? So why we are doing this implementation when we have our own shared ptr class? The simple answer is because we want to learn C++ in more depth. That's it. If you are able to implement what you can see that is available for you, if you can do that, then it means that you are very much clear about the concepts that have been introduced. And you can use these concepts while creating your new classes, while writing the code. Your piece of code that you will write will be of a good quality, of a supreme quality, right? So that is why we learn everything, whatever we can see. We try to implement whatever we have seen, right? So this is not all about the reverse engineering, but it is all about, like, we know that how it could have been implemented. So we basically understand the syntax, semantics, and the logic, underlying logic behind the implementation that was done in the real library that has been provided to us. Okay, now let us see how to use this shared pointer that we have written. So let me just use this shared pointer, but before that I just need to create one integer pointer equal to new int, and what you need to do, asterisk p is equal to 100, and then what you need to do, underscore shared ptr sp1 and then pass this p. And what you need to do, you need to provide it here like int, right? Because the type is int. One thing we forgot, like we have to initialize this resource count because it's a static variable, so we need to initialize it. So how we will initialize it? I hope you know how to initialize a static variable inside a template class. So that's what I'm going to do. If you don't know, just see how it is done. So you need to write like template class t and then write like int and then underscore shared ptr and then t and then you need to write n resource count is equal to 0. That's it. So this is the way how you implement, how you how you initialize a static variable for a template class, a static variable which is inside a template class. This is the way how you can do it. Okay, now let's do the very basic thing. We just want to see if our code is working or not. sp1, so it is working or not. So let's see. So let's run it. Yes, it is working, right? So basic thing like our this thing like asterisk operator and this pointer to member operator, if you want to get the that particular object, then you can see like this will also work. Okay, so let us do another thing like shared ptr int sp2 and it's sp1. Here I have used the assignment operator, sorry, the copy constructor. Now I'm just going to do like underscore shared ptr int sp3 and then sp3 is equal to sp2, right? If I do like this, I hope you know, if I do like this, then you know that it's not like the assignment operator will be called. The operator which will be called is the copy constructor, not an operator. The copy constructor will be called, right? Even if you directly write equals to sp2 in that case. But here, the copy constructor, not the copy constructor, but the assignment operator will be called. Okay, so let us do an experiment like sp3. Let us print sp3 and let's see what is the output. 100. Let us print sp2. What is the output? 100. And sp1 also gives 100, right? So this is the way you can use it. Now let us use the move operator and let's see what happens. First of all, let's do the use of move constructor. So if you write something like this, move sp2, then in that case the sp2 will be moved to sp3. So whatever sp2 is pointing to, that area, that memory area will now be pointed to by sp3. So this asterisk sp2 should not give any results. Okay, it should crash. But here it will not crash, let me tell you, because it's an online compiler. I'm using an online compiler, online GDB, right? Just for the sake of writing the sample code and not loading the entire Visual Studio .NET. That is why I'm using this online compiler, and I hope you can understand like it's not very much mandatory like I use that Visual Studio IDE for explaining these concepts. So let's see what happens now. Okay, you can see like nothing has been printed here because in real sense this will crash, but here it is not showing anything. So if you write like sp3 now, so sp3 will contain 100, right? Because sp3 is now pointing to what sp2 was pointing to, right? So let's again see the other thing like using the move assignment operator. So sp3 is equal to move sp2. So now what this statement will do, this statement is not going to call this function, this move constructor. This is going to call this move assignment operator. This is move constructor, and this assignment operator will be will be called when you perform the move operation using the assignment operator. right? So again the result will be same, but at this time this will be called. Okay, 100. So this is fine because we are printing sp3, so it is 100. When we print sp2, it will not return anything, it will not print anything. In fact, when you run in the real program, when you will run a real exe created using the Visual Studio IDE, in that case it will simply give you a memory exception error. Okay, so now let's see one thing, one more thing which is left here is the use of the destructor. Let's see if it is doing the resource counting, right? Then we should get a proof like it was using the resource counting, right? So let me do one more thing here. Let me write the shared ptr destructor, and here first of all what I will do, resource count minus minus, if n resource count is equal to 0. Once it becomes to 0, then what we will do, we will print endl now destroying the allocated memory for the resource. That's it. But to indicate that whenever an object is going out of scope, then we are calling the destructor. So for that we can do something like this. Call the destructor. Okay. So now what we will do nothing, because when this program will come to an end, then these objects will go out of scope. So when these objects will go out of scope, then their destructors will be called. So ultimately, when the resource count will become 0, then in that case, it will be destroying the allocated memory. Okay. So let us see what happens. So what do you think? How many times this destructor will be called? We are using move operation once, and we have created 3 objects. But for the move operation, there is nothing like resource count is incremented. So for the move operation, any kind of move operation, either it done through the assignment operator or done through the move constructor, resource count is not increased. Okay. So if the resource count is not going to increase, then what will happen? Only 2 objects will be there, sp1 and sp3. So the destructor will be called twice, only twice. Okay, one will be called for sp3, and one will be called for sp2. So twice you will be able to see the call the constructor destructor, and then after 2 calls to destructor you will be able to see this message. So let's run this. Okay, there is some issue maybe because we are doing this sp2. So let's remove this. Okay, now call the destructor, now destroying the allocated memory, call the destructor, because the other destructor was called for that object when you did move operation, so it was destroyed, right? So if you want to see it clearly, if you want to understand it clearly, let's not do all these things. Let's do simply like sp3, and then sp3 is equal to sp2, simple operations. Now we have 3 objects, sp1, sp2, sp3. So 3 times the destructor will be called, and then this will be called, now destroying the allocated memory for the object. Okay, so this is how it has been done. So don't worry about these things which are coming in between. It will it will simply decrease the resource count. This order this is the online compiler, so this order may be wrong, right? So you just need to check how it is calling the things. Okay, so sp3 is equal to sp1 or sp2, whatever you want to do, you can do that. So here at every point, like assignment operator and copy constructor, we have just done this, the plus plus, right? So this will work fine. So run it on your own Visual Studio IDE, there should not be any issue. Okay, so I hope you got the point and you understood the concept. So if you want to do it at your end, please do it. And if you have any questions, please put it on the comment section. Thank you. Have a nice day.